Let's say we want to create virtual reality social space that runs in the browser. This is what the XR.space project is, and this is an architectural overview for building such a platform from scratch. So let's start with defining some terms. A client is a browser. It can be a desktop browser, it can be a mobile browser, or a head-mounted display like the Oculus Quest. And these clients need to communicate each other, and will do so by connecting to a server, which will forward these messages to each client. This intuitively works because if client 1 says, hey, I moved over here, if that message is received by all the connected clients, then they can draw that client 1's avatar in the new position. So each client is running an independent simulation, 3D software, that draws everything in the space, and they're just communicating by messages, but they're all running that independent simulation on each client. But if a third client joins, they weren't there from the beginning, so they didn't get those initial messages. It's possible for client 1 and client 2, they entered initially, and maybe they changed the scene already. Maybe they added some boxes, moved some things around, collected some items. When client 3 joins, we need to bring them up to speed, so we need some way to share all the previous stuff that happened so that they can start receiving new messages. And so I introduced the concept of a snapshot, or sorry, a state. So a state is simply some in-memory persistence that says these are all the things I should be drawing in the scene. Some of it's not visible, so it's how much health people have collected, how much bullets are left in the chamber of the gun. So not all of it's visible, but it is the state of the world. So for example, let's say that a client 1, maybe they picked up a gun and they pressed that trigger button on an Oculus Quest controller. So one way to do it is we can send a message to the server and say, hey, we pressed that trigger button, and then the server would send it to everybody, including ourselves. But then this adds a round trip delay here for that message. So this arrow here says we should be as responsive as possible for the client itself, and everybody else wouldn't know the wiser. They're just receiving it with a slight delay everywhere else, but that's fine. But for yourself, when you click that trigger, you want to see that bullet fire. You hear that sound immediately. So we're going to send ourselves a message and update our state, and maybe that state would say that, oh, there's a new bullet flying across the screen. So then we send that message, this event, to everyone else, say, hey, bullet was fired, and client 2, if there's a side effect, it will also update its state. But for a newly joined client, they don't even know what people are there. They don't know if there's any monsters or whatnot. So we need to first catch them up on the state. So the server needs to retain a state as well. So everybody's kind of updating a copy of state. Client is retaining copies of state. Obviously they need to because they're playing a game. They have to keep track of every object. And the server should keep a copy of the state in case any client is disconnected and they come back, they need to rehydrate their own state. The server can give them a copy of that state, and that brings them up to the same page. Now this state is probably in memory for every client because the client doesn't really have a database to persist it, and their things are changing quickly. Everything's in memory here. The state should be the same across every client. And on the server, if we're going to host multiple games, we could hold probably everything in memory just as the clients do, but most of the time not a lot of it's changing. If you have walls and floors, they don't tend to really change, so we don't need to hold these permanently in state. So my proposal is that we if you get an event that changes some object, yes, you update that, but then you periodically flush that into a cheaper form of storage, which is onto the disk, into the database. So things that are changing a lot, like positions, people's movements, that changes so often, because if you're even just wearing the Oculus Quest headset, the number of events that you're generating just sort of by holding still there's still little tiny bits of movement. Put that over here in memory, and then occasionally broadcast it to everybody else. But other things like I picked up a gun, or even if I shot a gun, that happens at a much less frequent state. We can flush that over here. So when a new client comes up, we give them this a combination of these things. They say, hey, this is a more complete picture, but this allows us to purge the memory so that we're using much less memory, because if things don't change, we just shove it over here, and then we only maintain an object of those things that have changed. So what is this state? What does it look like? Well, here I'm borrowing from a concept, a design pattern called the entity component system. It may not be how it's implemented everywhere else, but this is my interpretation of it. That we need a way of describing the world, the scene, the state, all of the stuff that we care about. And the way we're going to represent this information is that everything in the space is an entity, and an entity is something with an ID. For example, something with ID 1, something with ID 2. It could be a string, yada yada. And this entity by itself doesn't do anything. It's just to keep track that you have something that you care about. And associated with an entity are components. So entity 1 has these components, entity 2 has these components, and the components have unique names. So there are a certain fixed number of components that are associated with certain systems. The components are just data, so it's going to be a name of some component, and then some data which I haven't shown here, which could be a vector 3 for position. We can also have a component like rotation, scaling, and those would all be vector 3s as well. Shape could be a component with some data that describes maybe certain prefab primitives like cylinder, box, cone, a plane, etc. Or you could have another kind of component that is representing a light, and maybe off of the data of a light could be the intensity, the color, etc. So you can imagine that this is very free-form data, but it's not arbitrary. It has to be of a specific schema that's recognized by a system. And the system is where you put all the code. This is the thing that's actually running on the runtime, running with the engine in that update loop that is listening for, has this thing crossed the threshold? Should I fire in a message? Or did you actually grab this thing? So all of that functionality is pulled off into a system that will update specific entities and their components. So entity and components, just data, all the behavior that operates on that data and makes changes to the scenes in the system. And so this is good because entity and components can be totally described, because it doesn't have any code in them now, can totally be serialized into a snapshot or state. This is exactly what, if you put it on disk, wrote it into a file, a JSON format is compatible with that. It's just a list of entities. So you can have an entities, which is, here I put a list, but it can also be an object with unique keys, and then just a list of components, or an object of components that have the different key for the different component name. So a unique component can only be on an entity one time, but the data can be customized for that component. So this is very easily serializable. You can write this to disk, and looking at it, you just say, oh, this scene is made of this. Another scene has different entities or with different components, and based on the components, it encapsulates some kind of behavior. So it's essentially a program, right? You can have monster spawners, guns, health, and they're just a component that says health, and it has some things that you might need, like the position of that health box, but it will just it will work at runtime based on the behavior of the associated system. And so this is sort of the flow of events. You have these different clients, and they're updating the server with some thing that this particular client did. They moved somewhere, or they clicked somewhere, they did something. And the server will enhance these events, put them in sequential order, and enhance them with a sequence number and a timestamp. And at any time, the host of a space can say, I want to build a new snapshot. So the server is also processing these events. So on every event, it's building up that in-memory state, which is really just something like this, right? So an entity change or a component change, and it has this. And then because this list is growing very large, if things are changing, we'll flush it to the database, and then so only those entities that are being touched will be here, and we'll just periodically keep flushing this. So this has the whole big picture of the state, and then this state is at the head of all the latest events. So this just continually updates. But if you wanted to save a version at a point in time, so this is the head right now is version 102, you could save that down here. But previously, along the way, while you're playing, you could continuously save other snapshots, and they would have the world as it was at a point in time, this one being the sequence number 53. So events are more or less free form, but they all follow some structure. The design is, because our state is always a list of entities and their components, the only messages that can possibly modify this state are a new entity is created, in which case you just give a new entity key and the list or object of components, or an entity is deleted, like you no longer want to see it in the space, in which case you could update that entity key with some tombstone that says delete this entity. That way you're still merging something in there. Component, everything else is an entity updated, but you kind of don't need an event for that, because to update an entity is to update its components, because an entity is nothing but an ID, which is immutable, and a component, which can be changed. So it could be component added, component removed, and component updated, which I think the majority would be a component type of updated. So this, I think, is sufficient for updating the state, and therefore these snapshots, which are really just different versions of state over time. And finally, there's an escape hatch, which is for everything I can't think of here. Maybe you can send a message to the other clients that you want to have some effect, but doesn't actually change the state of the world. So we're not going to create a new entity or modify anything, because if you could, then you would just send one of these messages. And sometimes maybe it's not worth it to do it. You can send a custom message to inform the client to do other thing, and maybe based on that message, it will inform them to create one of these kind of messages. So essentially, all the different kind of messages are these 5 or so, and they're always just merging they're just patching that state object. So an event like, hey, a door was opened, probably becomes 2 events, because it's going to be a component updated fact, and here the component you're updating is that it is the acts like door component, and you're changing it to opening. But this would change the snapshot or the state to have this door continuously opening. So you need one more event when the client that opened the door, when that door finally reaches its full height or for fullest opening, then send another message just to say that it was opened. So that way, when a new client joins and wants to get from the server a state, it would get, oh, here's the entity for the door, and here's the component, and it's opened. Same thing with firing a torpedo, which is a slow-moving missile. You would create an event. A client would create an event that said, "Oh, I'm triggering a torpedo fire now," and that might be a new entity. It's creating a brand new entity ID with components like it acts like torpedo. It has an origin and a direction and a speed, and it's going off into the distance. But that client also has to be responsible for the cleanup. So you can't just create entities forever unless that torpedo is never going to go away. I feel like once it's 500 meters, maybe a kilometer out there, you should clean it up. So you're never going to see that. So that client should create an entity deleted to clean that out. But bullets are kind of a maybe an exception, because this is where the custom message might come in, because sometimes you would double the number of messages you need. For example, if you fire a entity created for every bullet, then anytime it hits the wall, you might want to do a deleted, and this message might be delayed because we have a rule that the client that creates that event should also do the cleanup. But there might be a bit of a delay when the bullet hits a wall and the client 1 wants to remove that bullet, but in the other clients, that bullet has already hit the wall and has gone beyond the wall by the time it gets that deleted message. So the bullet system, on the other hand, can just decide to create that bullet and delete it themselves without having to receive that second message. So then we could just create a custom message to say, yeah, a bullet was fired, every system clean it up themselves, and we just don't bother with the entity creation at all, because the bullet is not really sticking around for that long. So do we really need to update the state with that bullet? It's a judgment call. In the case of a torpedo, we did, because it's slow moving, it's large, everybody can see it for a long time. And in the case of a bullet, pew, 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 you're not going to see them, they're gone. But the client will be responsible for damages that bullet creates, like if it's destroying a monster, or that secondary event for monster being hurt should be created by that client. Finally, I think this pattern leads us well to sets us up for different kind of scenarios, and so now we have a space that is really just kind of like a holodeck. It's running a program that is that snapshot. So by default, when you create a space, it has an empty database, an empty state, and as you design the space, you're pulling things in, you are adding to that database state, and by default it would just be retained. So the next time you come into that space, the objects that you drew before are still in there. If you add a couple more objects, leave the space, when you come back, those other objects are still there. So that is the default behavior. But sometimes you do want it to clear back into a state, and that's where you can use that snapshot. So as a host, you can create a snapshot and then put that in the space settings. So if a space has a snapshot associated with it, then every time a space restarts, because states are based on kind of ephemeral memory, when you visit a URL, if a server isn't running, it will pop up and either load the database that it had, but if it has a snapshot, it will open up into existence, load into existence, and first load up that snapshot, and it'll purge the database, and it will load the database with that snapshot, so that essentially every time we restart the gen server, you get a clean state starting from the snapshot. And finally, a space can have permissions of who can edit the space. And normally by default, the host can edit the space. Nobody else can edit the space, but the host can grant permissions to everyone else or select people, or can make it so that nobody can edit the space, which might make sense in a game where you don't even want yourself to be able to edit that space. So with these, I hope that we can start working on these scenarios. So one, a collaborative edit of an interactive space. It can be a bar or maybe a game or art exhibit, and you can, everybody who is enabled, so you just allow editing for everyone, and when they're editing it, they're personally editing it, and when they're not editing it, they're personally not editing it, and then they're testing the space, which means that all that means is that certain objects that you pull in, they have certain behaviors, but when you're editing it, they don't exhibit those behaviors on you. They exhibit it for everyone else. For example, if you pull in a monster, you had to be in editing mode to pull in that monster, and so that monster won't attack you, but you're immediately able to test it because they're going after somebody else. If you pull in a gun, as long as you immediately exit the edit mode, then you can pick up that gun and you can shoot it. Otherwise, you can't really fire that gun in edit mode. So this is that collaborative editing space, and then if you want to present it, just save that snapshot and then put that snapshot into the space, and now it is going to always reset to that space. So people can even come in and they can look around, and they can even maybe even open some of the edit menus and do other things as long as they're allowed to, and it will still reset back to its original position. So it's still some ideas to be fleshed out here. A VR podcast, which would allow you to, with everyone's permission, record the voice and the movement and be able to have a space where all this activity is played back as a virtual tutorial. And in that space, you should be able to follow the tutorial along by opening up your menu and building and sculpting along with everyone else. Finally, games. You want to be able to create a space with initial snapshot and then turn off editing, so you can't modify the game when you're playing with other people, because that wouldn't be fair. And that kind of concludes the architecture in terms of message and how we persist them. And then so now it's really just about designing all of the various systems and creating some snapshots that can be loaded into these worlds to see if we can actually accomplish this. So we'll see if this kind of architecture actually works.